All right, welcome to INSEAD Digital. Welcome to the TED Talk X. My name is Henning Piezunka. I'm going to talk about from chess to careers, unlocking GenAI's training potential. We are very happy to have you. We are honored to have you. This is a webinar that we organize in proud partnership with Accenture, who have kind of supported us through this. Excited to have them on here as a partner. My name is Henning Piezunka. I'm an associate professor of entrepreneurship and family enterprise at INSEAD. All right. So I would share my slides now. Next. Oh, a short note on the webinar etiquette. My guess is you've all been to a few of those, so I'm going to be very quick. You're muted. However, the Q&A is open and I'm very, very keen on hearing on you. So this is really like supposed to be interactive. I will constantly have the Q&A open. So I will time to take for the Q&A at the end, but I will constantly monitor them. So if you have a question right now, please feel free to type it in right now and I will try to kind of weave them in and answer them immediately. You can also upvote questions, so I'm always happy to kind of answer these questions at the end if I missed something as we go along. So I will always look at the most recent question, but I will take a few minutes towards the end and then answer them. The webinar will be recorded. However, I think this concerns more about what I'm supposed to say and not supposed to say. I'm not sure if your questions will be recorded. So, but you can also, if something was too fast for you, you can go back in time. But in general, my advice would be try to really focus for 60 minutes, get out as much as you can, and then move on. If there's a digital issue, you can always send an email to digital@insead.edu. But if you've come until here, you should typically be fine. Alrighty. And I think now I can share my slides. So here we go. So what I will talk about, and this is very different, you see. So, and different, not necessarily good way, but it's different. You will attend a lot of talks these days who will talk about the effect what GenAI might have in the future and how it will change the role of managers and stuff like this. And let's be honest, all of this is speculation, okay? Most people who talk about this simply try to second guess what OpenAI will do or Microsoft or Google will do in the next few months and how it might have an effect on managers. But we are all just trying to make sense about the future. We actually do not know, okay? What I have done is different, okay? What I've done is I've actually gone in the past and I've looked at the effect that AI had in the past. And I look in an industry where AI has actually arrived in the 1970s and has been very prominent. And I look at how it did affect people's careers, how it changed the industry, so how it was a true game changer. And so what I then would love to do with you is let's look at this one case where AI has already arrived in the 1970s, okay? And then we look at what happened in that industry, and then we think, okay, what might that do in other industry? And I have a few ideas, but I'm very keen to hear from you, to hear your questions, to hear your ideas, okay? So we will look at, as you can already see from the slide, we will look at chess computers, okay? Before we kind of dive right into the middle, some of you have already contacted me and know me. However, let me give you a little bit of background. I typically live in Paris. This is not my apartment, but the kind of apartment I'm living in. This is the Fontainebleau campus where I typically work in its beautiful vibrancy. This term, I'm actually not at Fontainebleau. I'm at the Wharton School at the University of Pennsylvania, which is a fantastic partner school of INSEAD. I'm originally, you might have already heard this from the accent. I'm originally from Heidelberg, Germany. Fun fact about Germany, there is no fun in Germany. So let's all go back to work. There's a different way of telling this joke. What's the meaning behind the color on the German flag? The black, the red, and the gold stands for work, and the blue stands for humor. In case you're wondering, that's about the same reaction I get when I tell a joke in the classroom. It's absolutely dead silence, okay? A little bit of background for me. So who are you hearing from? I already mentioned I'm an associate professor of entrepreneurship at INSEAD. I studied at the University of Mannheim, Sciences Po, London School of Economics, and Stanford University. If you ever try to figure out whether someone went to Stanford, how can you do it? Don't worry about it. They will tell you, all right? I've already seen how these kind of things work in practice. So actually, before entering academia, I was the founder of a web design company, which I sold in 2016. So I know a little bit IT. I wouldn't call like web design is very far away from deep tech, but I know a little bit my way around computers, okay? So I teach this kind of material to PhDs, MBAs, very often executives. I do a bunch of consulting with companies and so on, and we'll kind of try to figure out AI and how they can leverage it. How can you get the most out of this class, out of this webinar for the next 60 minutes? Look, I want you to kind of squeeze this out like a lemon, okay? So that you get the most out of it within the next 60 minutes. I would say there are 4 types of learnings which apply here, but frankly, these apply to any kind of learning, okay? So the first step is, I hope you can steal as much as you can, okay? By stealing is, you take something that I say and you can use it in a different context. So you learn something about chess computers and this, and you walk away and say like, go to a colleague and say like, think about chess computers. And you sound smarter than you actually are. But look, this is how this always works, right? We're always stealing from somewhere. The other thing is, you draw some inspiration from this. So you might actually say, hey, you know what? This is something which worked in this context. So this is something Henning said, and maybe we can apply this in our kind of GenAI strategy. And that's absolutely fantastic, okay? So there's stuff that you immediately find useful. Then there's stuff which I call an oyster, okay? That's stuff that you find interesting, but which is not necessarily immediately useful, okay? So I give you an example from my own kind of background. I was big in Formula One as a teenager. I really wanted to learn everything about Formula One, but it really served absolutely no usage. But here's the thing, 15 years later, I wanted to understand what's the difference between high-performing organization and best-performing organization. And what better context is there than Formula One? So all this kind of knowledge that I built up from watching all these Formula One races when I was a teenager actually turned out to be useful, okay? And so I published a bunch of papers on Formula One. In case you're interested to learn more about Formula One and how you can research this stuff, just kind of drop a note in the Q&A, and I'm happy to send this to you. You can also contact me on LinkedIn if you're interested in it, and I'll share the research with you. And the last category is what I would call simply causes you discomfort. There might be stuff I say where you say like, I strongly disagree with this. Henning has no idea what he's talking about. I don't understand it. And that's fantastic. If I would only say things that you immediately understand, okay, it would make very, very little sense for you to attend the webinar. So hopefully there are a few things where you say like, oh, I don't fully understand that. I don't fully get that, okay? So these are kind of the 4 categories: stealing, inspiration, oyster, and discomfort. What I'm going to do, and this is very, very atypical. For those of you who've ever seen me present, I normally kind of present like a well-structured, pre-chewed kind of insights, which you can immediately kind of apply. So this is much more like my MBA teaching or my executive teaching. What you see today is me presenting a scientific paper. Okay, so I'm basically showing you regression tables. I show you in great detail what's happening in the context of AI or Gen AI in the chess industry, okay? So it's very different, but hopefully something interesting, something new, and you might actually get an insight about, okay, what does INSEAD kind of do on this research arm all the time, okay? This is joint work with my fantastic co-author, Fabian Gessler, all right? So look, the thing we are thinking about, and this is what this is all about in many ways, is this is about strategic interactions, okay? And many, many interactions in your life are truly strategic, okay? So if you think about it, you know, when you negotiate your salary, it's a strategic interaction. When you delegate a task, it's to a certain degree a strategic interaction. You know what? Before everyone posts their email here, how about you just connect with me on LinkedIn? You can either connect with me or you follow me. And then I'll share it there. That might just be easier for everyone, okay? There are 400,000 thought leaders, but luckily there's just one Henning Piezunka. Let me kind of see if I can quickly post my, oh, here we go. Let me, you know what? I'll share this quickly via the chat. So if you're interested to learn more about Formula One and what differentiates good performing companies from best performing companies, just follow me on LinkedIn, and everybody who kind of follows me now, I will post that stuff there. Okay, wonderful, super. All right, look, we've come from 2 open questions to 2 answered questions. Fantastic. All righty. Let me, my slides didn't work anymore, but that should be quickly solved. Here we go. So all kinds of strategic interactions where you really kind of interact with other people. You see, like in your career, it's typically interpersonal interactions, but in your kind of outside of your career, you also have lots of strategic interactions between companies, right? If you partner, if you compete. So there are lots of kind of incidences where you really kind of engage with others in everyday life, okay? And you need to respond to one another. The problem about this stuff, it's very difficult to train and it's very difficult to learn. So let me give you a very simple example, okay? For example, I'm an amateur runner, okay? And running is relatively easy to learn, okay? I can just put on my shoes and I can go out and I can run. It's as easy as that. I might need a training plan, but I can do it all by myself, okay? And I can become a pretty good runner if I'm willing to kind of make myself subject to the corresponding training regime. Now, here's the thing. Learning soccer is much, much harder, or tennis, because it's very difficult to become a very good tennis player completely on your own. What you really need is a training partner, okay? Tennis is an interactive sport. Soccer is an interactive sport. And so you need somebody to train with, okay? The problem about that is having somebody to train with, you need somebody, and it might be very challenging to get a lot of people. So I give you a simple example. Let's take this setting, okay? So I can obviously train this presentation on my own, and I can design the slides and stuff like that. But actually dealing with Q&As is actually getting much harder, because to actually deal with Q&As or with questions more general, I actually need an audience, right? And so that renders the whole thing more challenging. The whole hypothesis about this paper and the whole kind of my hypothesis about GenAI in that sense is that we can use GenAI to actually learn all kinds of strategic, or if you want to put it more broadly, even social interactions. What do I mean by putting it more broadly? Look, they're strategic interactions, but they're also just social interactions, which might be strategic, might not be strategic. You see, you might actually struggle to go to a dinner party at your at your employer. You might also simply have a hard time in interacting with friends. You might have a hard time going on a date. But it's very difficult to train these kind of things, because you typically need somebody who you talk to, okay? So look, organizations and decision makers frequently engage in strategic interactions, right? Company level, airlines setting capacity, in auctions, right? You see, imagine you try to buy real estate, okay? You put a price, the seller puts a price, you put a price, the seller puts a price, and so on and so on, okay? And in case you're interested, this is obviously nothing I've said originally. There are Nobel Prize-winning economists who have worked on these kind of questions, okay? But then it's very challenging to master strategic interactions, okay? Look, you need to do so many things. You need to anticipate your competitor's response to an action. There's such a large number of scenarios, right? Think just of any conversation. Depending on what you say at one point in time, this might go in a completely different direction. It's really very difficult to keep an overview over all these different alternative scenarios, okay? There is what researchers call an enormous amount of interdependence. So the effectiveness of something I do, okay, is completely dependent upon what you do. So think about two soccer tennis players, okay? If I play to the left and you run in the opposite direction, well, that's great, point for me, okay? But that doesn't look as great if you stand exactly where I shot the ball, all right? So it's the effectiveness, whatever I do, really depends upon what you do. And so it's difficult to figure this out, okay? Now, there's this thing which is called credit assignment, okay? What credit assignment basically means, it's an attribution problem. So you think very carefully about, okay, let's say I won, or let's say I lost. What was that due to? It's not necessarily evident why you lost, if you lost, and it's also not necessarily evident why you won, if you won, okay? Look, it might have been, let's say you go into negotiation, okay? and you actually kind of get a salary increase. Now, why is that due? What is that due to? Is it because your boss had a good day? Is it because you wore a nice shirt? Or is it because you looked for the right formulation and so on? So credit attribution in social interactions is incredibly difficult, okay? So Ada, very much thank you for the questions. I'm curious if you used any insights from this concept on this webinar presentation itself, considering the audience attention, focus on orientation as strategic interaction. I have noticed some elements already. Ada, before I answer the question, now I'm very curious about the elements you've noticed already. Why don't you share them in the chat, okay? Or like in the chat or in the Q&A, and just give an example of these kind of elements you've already noticed, and then I'll comment on it. But before, I don't want to kind of precurse it, okay? So you tell us a little bit more what you've noticed, and then I go into this, okay? So how do you can decision makers actually learn strategic interactions? Okay, that's the big question here. How can you figure these things out? Okay, now look, how do we learn strategic interactions traditionally? You read a book. Okay, sure, you can read a book. That's great. You see, probably all of us on this call have read some negotiation book. Okay, how do you get to yes? How do you not take a no, or whatever? How all these kind of negotiation books are called. Okay, so that's really nice. Okay, here's the problem about it is it's non-responsive. Okay, so you read the book. All right, you read the book and you start developing ideas and you think like, oh, this is what I'm going to do. But the book can't give you feedback on that. Okay, so that's not great. The wonderful things about books is the availability is very high, right? You know, you can kind of scale this at infinitum, right? So, you know, in particular of digital books, the marginal cost of producing one more book is basically zero. So this is fantastic, okay? So now the other thing about it is, look, experiential. You engage in the actual strategic interaction. Okay, look, this is fantastic. Okay, let's say I want to become better in salary negotiation. What better training could there be? Okay, that I actually go to my boss and say, hey, I would like to negotiate my salary. Okay, so I'll do that and I get a realistic response. Now, the problem about that is this is freaking expensive. Right? So in the following sense, I can't go to my boss on a regular basis and negotiate my salary, right? So imagine I go to my boss and say like, hey, you know what? I'm just completely underpaid giving my performance. You need to give me 20% more salary. And my boss just says, you're ludicrous. I'm not even going to engage with you on that basis. Okay. And then I walk out, but now I can't go to my boss for another year. It might have been perfectly fine if I had said like, look, I've made an extra effort. Can you give me 5% or something like that? Right. But I don't have a second shot. It's not as if I close the door and say like, hey, let me try this again. Okay. So it's very limited and potentially very expensive because I might ruin my reputation. Now, I can train with human training partners. So let's say I want to negotiate my salaries with my boss, but I know I can't kind of ask my boss. So I might ask a colleague, okay, and say like, hey, can you train with me? Now, the problem about it is the realistic responses, well, hopefully they are realistic. You see, like in my case, I need to negotiate my salary with the Dean of Faculty at INSEAD, okay? But the Dean of Faculty at INSEAD will probably think about my salary very, very different than a colleague of mine, okay? So the training with the colleague might not actually be particularly helpful. The other thing about it is, you see, I can only do this with a colleague who generally understands how the Dean of Faculty at INSEAD thinks, okay? Now, the problem is, of course, there are not many faculty at INSEAD who are senior enough to understand how the Dean of Faculty thinks, okay? So I don't have lots of training partners, okay? In particular, when it comes to more critical interactions, all right? So I give you a simple example, which I like a lot, okay? So, and I discussed this actually with a pro coach, and he pointed out, he said, like, you know what? Roger Federer is obviously one of the best tennis players ever alive. But here's the thing, he doesn't have a good balance against Nadal. But with whom can you train to play against Nadal? Because Nadal is simply one of the best tennis players himself. Okay, so it's very difficult to train. You can't go to your local club and say like, I'm not so good. Can you please help me? I want to beat Nadal. So you don't have access to a lot of training partners on that level. Okay, so now look, I'm not telling you anything like what I'm going to go for is like you can use simulations, but here's the problem. Okay, we had simulations all the time. You've probably, when you were in college or when you were in school or when you did driving school, when you get your driver's license, you probably engaged in some conventional simulation, right? You might have all kind of you might have all played simulation games on your computer, right? Like there's, I think, a Microsoft Flight Simulator, there's an infinite number of racing games and so on and so on and so on. Okay, here's the thing. So conventional simulations don't give you a realistic response. Okay, they are very good in modeling physics, but they are not very good in modeling social interactions. Okay, you've seen this when you play a racing game, right? You see, like, you might actually say like, oh, the drifting is realistic and kind of the barriers are realistic, but very often your driver opponents are not realistic. Okay, suddenly they can just accelerate like crazy, or they can violate the laws of physics or whatever. Okay, so you don't actually get a good feeling, right? So if you're Lewis Hamilton or Max Verstappen and you drive Formula One, it's not easy actually to train with you for like just doing sim racing. Okay, assuming the sim racing is done by other kind of AI. All right. So the nice thing about conventional simulations, look, it's a technological solution. It's super, super highly scalable. Okay. So that's really nice about it. So what you're seeing here is there's a little bit of a trade-off between responsiveness, or you can call it interactiveness, and availability. Okay. Let me kind of give you a summary here in the chart. All right. So no response you get from like book, lectures, and so on, right? So look, this is just an example, right? Imagine you're sitting there and say like, it's interesting what Henning say. This is how I'm going to use this in my career or in my professional life. Okay, look, I can't give you a response. I don't even see you. Okay, so you can think whatever, but you're really just thinking it. Okay, and this is a real downside of these lectures. I think it's great. You see, like, we have more than 200 people on the call, and that's fantastic. So it's really scalable. Okay, but at the same time, it's not interactive in that sense, right? You see, like, we have the Q&A, but that's not sufficient for you to kind of actually try out Gen AI in your personal life and be giving feedback on it. Okay, then there are conventional simulations. Okay, sure. So this is kind of the flight simulator. So now they're human training partners. And you see, this really kind of approaches it now from a different angle. You have actually low availability. Training partners are very expensive, okay? But you get a relatively realistic response, okay? And the argument that I'm making here is that AI-backed simulations can actually overcome this problem. They can give you a realistic response at a high availability, okay? And this is why we suggest that AI is a fantastic training technology. Okay, so please think about this for a second, because it's different how you generally think about AI. Okay, when you think about AI, you typically think about A, replacement, and B, augmentation. Okay, replacement would be, okay, there's a truck driver. All right, now the AI can drive the truck, and so we get rid of truck drivers. Turns out that's rather difficult, by the way, but that's the replacement idea. Okay, it might not be a complete job. It might also just be a particular kind of task, right? You see, like, for example, in a lot of our lives, we probably all hope that AI takes care of scheduling tasks, right? Nobody likes these 4 or 5 emails where we say like, hey, when do you have time? When do I have time? When do I have time? And blah, blah, blah. Okay, so we all hope that this kind of stuff, basically, no offense, but we hope that it replaces the need for doodle. Okay, so that's the replacement part. Then there's the augmentation part. Okay, the augmentation part is you're doing something, but AI just will make you better at it. Okay, so I give you a simple example that you're all using. You type in Microsoft Word on Google Docs, okay, and there's an AI in the background which basically helps you to improve your English or whatever language you're writing in. Okay, it recognizes the language, it figures out grammar mistakes, and you automatically get better. That's augmentation. Okay, so there's replacement and there's augmentation. Okay, what we are suggesting, there's also training. Okay, so it's not only that the AI replaces you or that the AI kind of helps you to perform better, but the AI might also simply train you. You keep the full task, but you just become better at it. Okay, so What's the main hypothesis here? As I said, this is a scientific paper. Decision makers can use AI-backed computer simulations to train strategic interactions. Okay, so what's the mechanism? Computer simulations. Chetty, you raised your hand, but I think, look, I'm not sure if I can even call on you. Thank you so much for raising the hand, but please put it in the Q&A. I will immediately engage with it. I also still hope to hear back from Ada with kind of the elements that that were already noticed. Okay, so these computer simulations provide decision makers with, and this is the key point, not training partners, but artificial training partners. Okay, so rather than having an actual human training partner, I can interact with an artificial training partner that can realistically emulate the behavior of actual competitors. I put this here in the context of competitive interaction, but look, you can just replace competitors here by any form of interaction partner. What's the mechanism? Okay, researchers always talk about mechanisms. Okay, it's what's called a scalable substitute. Okay, there's a bottleneck of human training partners, and we are saying, like, look, if you have AI-based simulations, it can actually replace human training partners. Okay, and so they can help decision makers to learn strategic or all kind of social interactions. Okay, so main effect here, do decision makers benefit from training with AI-backed simulations? Okay, we'll come to some boundary conditions a little bit later. How do we actually address this? What did Fabian and I do here? Okay, look, generally, it's crazy difficult to say anything about AI. I know your LinkedIn feed is completely full of AI and what people are kind of claiming, what's already doing and what it will be doing. Here's the problem about it, okay? They are currently, and this is something that Raj and Siemens pointed out in 2019, but I would make the argument that's still kind of true. There are currently no public data sets on the utilization or adoption of artificial intelligence at either the micro or the macro level, as most complete sources of information are proprietary and inaccessible to the general public and the academic community. Okay, look, we have very little data on the usage of AI in the world. And as a result, it's very difficult to estimate the effect. Okay, look, social scientist is in general a very, very difficult manner because there are always so many influence manners. But let's take a very simple example, okay? If you want to study the effect of what's the effect of the ratio of male to female board members in public companies, okay? Difficult for a variety of reasons, but at least you know the number of women and men on corporate boards, okay? And there's great research on that, okay? In the case of AI, you don't know who's using what kind of AI. You don't know which employee is using what kind of AI. And so it's very difficult to estimate the effect. Now, very scientific, lack of exogenous variation in AI adoption. What does that actually mean? Okay, look, you try to, the ideal version, if you wanted to understand what's the effect of AI is, you want to flip a coin and somebody uses AI and the other person doesn't. You flip another coin and somebody uses AI and somebody doesn't. Okay, so you get like an experiment. Okay, it's like the same way how a drug is tested in a medical trial. Some people use the drug, other people don't use the drug, and then you can determine the effect of the drug. Okay, the problem is life typically doesn't work like that because people typically decide to use something. So I give you a very simple example. Okay, if you just look at the correlation, okay, hospitals kill a lot of people because if you actually go to a hospital, you're more likely to die, okay? Here's the thing, so people don't go randomly to hospitals. People go to hospitals because they are sick, okay? And so only sick people are obviously more likely to die. The issue with AI might be that people who are interested in technology, people who are smart, are more likely to use AI. And so you might think like, oh, lots of people, the people who use AI actually do better. So what we need is some kind of source why some people use AI and others not, which is nothing to say about those people. And then, look, we typically lack a precise definition of AI strengths and even of performance strength. Okay, here's the question from Chai. Let's have a look. Question on the point about substitutes. For example, replacing truck drivers. Would you agree that these are not feasible small scale precisely because these systems are not good at modeling social actions? For example, other humans on the road. So it would only be feasible, successful in ecosystems where it can be done at scale and without exposure to other humans. Chai, this is a very good question. So I'm not a total expert on kind of remote on autonomous vehicles. But what you're pointing out correctly, of course, is you see, like, autonomous driving is in part so incredibly hard because you have so many other people on the Autobahn or on the streets who might do random things, okay? So your question can be answered by a very simple example. So if you look actually at AI-based autonomous cars on racetracks, where you just put one car on a racetrack, those cars do perfectly well, okay? They can figure this all out. You don't even need to tell them like, oh, this is how the track goes, this is where the curve is and stuff. You just put the car on, and this is something you were able to do like a few years actually ago, like, I don't know, 5, 6, 7 years, maybe even earlier. You know, there was a big project by DARPA at Stanford, where they gave like X million amount of dollars if you actually were able to drive a car through the desert and stuff like that. And that's relatively easy. The difficulty is that you need to deal with so many random things on the street. So even there, to a certain degree, it's the human interaction which makes things difficult, right? You see, like, look, if you have kids and you think about your kids learning how to drive, you're not so worried by itself that they are not able to hold the car on the road, but you're worried about that there's some kind of random freak accident where somebody didn't follow the rules and your kids didn't kind of manage to respond quickly enough. At least that's what I would be worried about. Okay. So what's the setting we are looking at? Okay, so we are looking at chess computers. Now you might be wondering, chess, kind of an odd example, but here's the thing. If you go back into the 1950s, you see that chess was really like the primary, how should I say, use case of artificial intelligence. If you look at pleasure, Chai, thank you for the questions. If other people have questions, don't hesitate to put them in the chat. So chess was really like the prime kind of instance where people try to figure out artificial intelligence and what it is. And you see, if you're interested in these kind of things, if you're interested in game theory, information systems, right, you see all these kind of famous names there, right? Von Neumann Morgenstern described chess in a game theoretical context. Alan Turing specified the first chess computers named Turocham. Claude Shannon, right, kind of the father of information system, published Programming a Computer for Playing Chess. And, 1956, the first proper chess programs by Alex Bernstein from an IBM 704. All right. So, and what you can see here, if you want to all geek out a little bit, okay, these are, for example, the first nodes by Alan Turing. Okay. So, and who you see here is Claude Shannon and Herb Simon, if I recall this correctly. Yeah. So, and now this is a moment many of you might actually remember, or actually heard of. This is when we are now on a completely different level. This is IBM Deep Blue kind of playing and eventually beating Kasparov in a game of chess. So this is really when we've reached dominance. Okay, so the moment when chess computers really dominate, when chess computers actually dominate individuals. Okay, so chess is kind of a strategic interaction. Okay, so players take actions and respond to one another. There's a large number of scenarios, difficulty of credit assignment. So everything that makes strategic interactions hard to learn is also true in the context of chess. Okay, and chess computers is really like an artificial intelligence. Okay, so there's something very funny about artificial intelligence, and maybe some of you have actually encountered this, and I would be curious about this. Okay, wait. Anonymous Atondi points out a typo, turning instead of Turing. This is embarrassing. You know what? Let's make this more embarrassing and go back. Where is it? Turing? Oh, you are right, by Alan Turing. Thank you so much to the anonymous attendee. Really appreciate it. Okay. So you might actually encounter this kind of argument a lot when you talk with other people about artificial intelligence, where somebody says like, oh, what you're talking about is not artificial intelligence. So I've looked a lot into this. And one thing that I found really interesting is that the definition of artificial intelligence has actually changed a lot over the last few decades. And the funny thing about this is, okay, whatever you think that how artificial intelligence is designed in the 1980s is not considered artificial intelligence anymore in the 1990s. And what is considered artificial intelligence in the 1990s is not considered artificial intelligence in 2000. So suddenly people would say like, hey, that's just pattern matching or something like that. Okay. So that's really, chess computers, I think is fair to say, were at least at the time a form of artificial intelligence. Okay, look, as I pointed out, no lasting definition, but chess computers kind of deal with two things that are generally associated with artificial intelligence. They cope with very high complexity and they emulate human thought. Okay, I mean, look, the reason why we talk about artificial intelligence is because it does human thought. Okay, so we look at chess computers. And now there is something beautifully, okay, empirically, but I think it's also just a great story, okay? So chess computers are around for a while. What you see here is like the chess computer at the time. You see here an IBM machine. This is one of the earlier versions of a chess computer, okay? But now the fascinating thing about this is, okay, now what you see here, these are like the first kind of dedicated chess computers. The Chess Challenger, which were actually kind of promoted. This is from the year 1977, the Challenger one. All right. Now, what we have here is data on 130,000 chess players. Martin has a question. How would quantum computing change chess computers? Martin, I can say with good consciousness, I have no idea. You know, it might be that look, there's obviously, so I can't speak on the question, Martin. I will say three things. So the evolution in chess computers has always been driven by three factors, okay? So one factor being simply the availability of better software, okay? So better algorithms. The other factor of it has been the evolution of better hardware. Okay, so just much faster machines so you can do more computations. And the last thing is you just simply add at some point more data. Okay, now what you now see, and this is kind of interesting, you see like the relevance of data has disappeared a little bit because you could see that you can generate a lot of data by just having chess computers play against each other. Okay, so suddenly you were not anymore constrained to like 8 million games that had been played, okay? But you could play basically literally millions and billions of games within a few minutes on a high-tech computer. So what I could imagine, Martin, is that quantum computing will just bring so much brute force computing power, okay, is that it will reduce the relevance of efficient algorithm and of data. So in chess, you see, I would say we are almost basically at the limit of that. It won't make such an enormous difference. So I think we're pretty much approaching the frontier of what's possible. But in other areas, for like more complex strategic interactions, that might actually make a big difference. So back to the data. What kind of data are we having here? But Martin, you might have your own speculations. I would be very curious on your thinking. Okay. You should also completely ask ChatGPT, by the way. Okay, don't trust my words. Let's kind of eat our own dog food here and try what ChatGPT says. Okay, so data on chess activities of 130,000 chess players. We have official chess play statistics from FIDE. FIDE is the body which covers all these chess players from 1970 to 2000. Okay, so this is, and Fabian gets a lot of credit on this. Okay, so Fabian collected all this information on chess computer, historical information on strength, price, manufacturing, okay, with data from ChessBase, which has 2.1 million games, with information, and this is very important, at the single move level. I'll show you later on, okay, why this is important, okay? And then what's the sample here? We have the former Soviet Union, and we have countries from the former Soviet Union and all Western European countries, okay? The one country we don't have is Germany, okay? So because we couldn't tell the difference between West and East Germany in the data, okay? It would simply say like a player is German, but we wouldn't know if he's East German or West German. There are other countries we've dropped, okay? Simply to reduce effort or to reduce computing power. You will see later on why that is relevant, okay? So what's the analysis? Let's start here with the main effect, okay? Do decision makers, let me go back, I think this was a bit quick. Do decision makers benefit from training with AI and AI-backed simulations? All right, look, what's the research design? Again, until 1977, nobody had chess computers, okay? So until 1989, chess computers are available in Western Europe. And then until the 2000s, chess computers are available in Western Europe and the Soviet Union. Okay, so to put this onto a map form, okay, you can see here one part of Western Europe, they actually have chess computers from 1977 onwards. And then we're looking at chess computers in the countries which are associated with the former Soviet Union, and they only have access to chess computers from 1989 to 1990. Okay, so going back to this beautiful graph, this is now what you want to have as a social scientist. You get this experiment where some people, without their own choosing, get exposed to chess computers and others are not getting exposed to chess computers, okay? We have a question about the environmental footprint. I'm happy to engage with this, but let's do this towards the end of the webinar, if that's okay. It's not topical, super relevant, okay? But it's a very important question, so I'll go into it, okay? So now what do we find with this kind of setup, okay? Look, we have chess computers. They diffuse in Western Germany widely, okay? But they're de facto not available in the Soviet Union. If you wonder why, it's very simple. The Soviet Union didn't have lots of microchips. Obviously, they could do the math, but because of kind of low global trade embargo and so on, they didn't have access to microchips. And because of a lack of microchips, the whole thing didn't really diffuse in the Soviet Union, okay? You can also see this here, right? If you look, for example, at Western Europe and the rest of the world, you can see on the left-hand side, I don't actually know, can you see I assume that you can see my mouse. You can see this here, right? You can see the number of models, and there are lots in the rest of the world in Western Europe, but hardly anything really in the Soviet Union, okay? And then here on the right-hand side, you see manufacturers, lots in the rest of the world, lots in Western Europe, but not really many in the Soviet Union, okay? So, Eloy has a question. Opinion: chess all relatively simple problem, simpler than Go, for instance, which already outpaced for AI by current algorithm computer power. Hence, quantum computing principle would not make much difference. So, Eloy, look, very good answer to Martin's questions, I believe. Okay, when you say relatively simple problem, I would say, Eloy, you say this with a 2023-24 mindset, and I fully agree with you, right? If you look at the 1970s, very, very complex problem, right? So in many ways, what we perceive now as a complex problem might actually be as simple as we now think of chess in the future, okay? Kevin Hack points out, Kevin Hack Young Yu, compared to chess, where there are a fixed set of rules to evaluate the outcome, how do you evaluate the validity, materiality, segmentation of data used to refine AI for decision-making processes, which can be incredibly complex? Are there best practices, variables that determine best outcomes? How are they justified? Kevin, this is simply an excellent question, okay? There is not a totally clear answer to this question, okay? So what you're basically saying, like, look, what you do with chess is all nice, you buy that. But the real world interaction is quite different from chess. And you know what? I would agree. So here's the thing, and I've spoken with a lot of managers about this, and like I'll do a bunch of consulting projects where we think about using AI in their firm and stuff like that. And so you see what it often comes down to is these very more complex interactions. Part of those is actually completely standardized, okay? But part of it requires then a little bit like, I don't know, what do you want to call it, human ingenuity. So I'll give you an example from airlines, okay? So you see like lots of airlines, lots of strategic interactions can typically be done by an AI. For example, route planning, how many planes you put on which route and stuff like that. How do you select prices, your yield management, you know, that's something where obviously can be done by humans, but computers are just much, much more efficient in it, in particular, given the time pressure and so on. But then there are issues which are not kind of easily solvable by the AI because they are not within the system, okay? So I give you an example. Have a guess for yourself how many Airbus 380 were sold to American Airlines, okay? And the answer is 0. Airbus managed to sell 0 Airbus A380 in the United States. And the reason why that is that to make full use of the capacity of the Airbus A380, you actually need to adjust the airport a little bit. You need to adjust the gates, okay? And so lots of American airports are actually co-owned by different kind of airlines, okay? And sometimes Boeing has a stake in those, okay? In the airport or in the airline even. And so I'm not sure if they have a stake in the airline, but they can influence the airport. And so what Airbus basically failed to do in that context was they did not correspondingly adjust the airport, okay? And that is something which was really outside of the thinking of the executives, and it was outside the thinking of like what you would classically do in a computer simulation. So Kevin, towards your point, absolutely, there are points the AI cannot take into account. Having said that, okay, what the AI can always help you, even if the system is highly complex, to get your basics right, okay? And getting your basics right will be a long way and will actually then free cognitive capacity for you to actually deal with the more complex issues, I would say, okay? So much about that, all right? So let me come back to the setting here on the effect of chess, okay? Martin has another question. Kevin, thanks for the kind note. Martin asked, I'm also thinking about the reverse effect, how I can enhance chess engines. Here's what ChatGPT came up with. All right, everybody figures this out when ChatGPT says, okay? So comparison Western countries and countries associated with the former Union. Look, then in 1989, 1919, kind of the Iron Curtain comes down. The best way I could illustrate this was to show you a McDonald's in Moscow. Okay, so we look at the main effect. What's the benefit from training with AI-backed simulations? Okay, how do we actually measure performance? For those of you who know a little bit chess, I saw we actually have a few people on the call who are actually into chess. I saw Sarah has already kind of her chess.com kind of panel on this. So multiple ways how you can measure performance. The most known is probably the ELO score. The ELO score is basically a score which is computed by who do you beat by, who do you beat, and that kind of then co-determines your ELO score, okay? There's some problems with the ELO scores as a measure in this context. So we are also using a different measure, which is called the so-called centipawn loss, okay? What the centipawn loss does is the following. You basically determine mathematically what would be the perfect move in a particular situation. And then you look at how far was the player's move away from that perfect move, okay? So we look at 2.1 million games. We look at over 150 million moves. What we have done, this is by far the computational and most complex paper I've ever written, and all the credit for this, most of the credit, but almost all of the credit should go to Fabian Gessler for this. Okay, so we then remodeled all of this, and we used Stockfish, some of you might know, is a chess engine, to replay all these 2.1 million games to evaluate every single move, okay? To give you a feeling, we took the biggest server that we could go get on Amazon AWS, and the thing ran for 6 weeks full time, basically to compute these numbers, okay? So what we do, we determine the best move, deviation, and differences, and blah, blah, blah. Okay, so this is how the data looks like. This is how data is typically coded up. You've probably seen this like in the New York Times and stuff like this when chess games are documented. Okay, so what do we find? All right, let's have a look. What we are seeing here, if you have access to chess computers, so if you're in Western Europe, okay, your ELO rating tends to go up and your centipawn loss tends to go down. Centipawn loss going down is a good thing. And your probability of winning a game also goes up substantially. Very simply said, having access to AI, training with AI, does make you better. It's as simple as that, okay? Look, this chart shows you, if you look on the left-hand side, you see this on the X, the effect size of being in Western Europe, okay? And just being in Western Europe between 1977 and 1990 gave you a huge boost. It was really helpful to be in Western Europe at that time if you were a chess player. Just being in Western Europe improved your chess performance, okay? So now you might, of course, say, Henning, all kinds of things happened in 1977 and 1999, 89 in the Soviet Union or in Western Europe. How can we tell that this is due to chess computers? Now, there's something very nice about chess computers at the time. Chess computers at the time were deterministic. So if you let them play white, they would always open with the same kind of move. So what players typically did is when they played with chess computers is that they themselves always played white and have the computer play black. Okay, and that way they can try different openings and try different kind of stuff and train. Okay, now what we find is that people get substantially better in training when playing white than when playing black. And you can see this because at tournaments, right? The moment they play a tournament, then it's random whether they play white or black. And in these tournaments, we see that their performance improves substantially more when they are playing white. To show you how big this effect is, okay? So let's say we have two players, both have an ELO score of 2000. So the chance of winning of each other is 35%. The likelihood of a draw is 30%. And now let's give player A access to a chess computer just for 1 year, okay? And that winning percentage now goes up by almost 10%, from 35 to 38%. Okay, and think about it. This is just the effect of a single year. All right. So don't trust me. Trust the world chess champion, Vladimir Kramnik. Technology has forever changed the world of chess. Today's players have access to strong sparring partners whenever you want to play, and they never get tired. Okay. Look, boundary conditions. Okay. So now we've learned AI can be helpful, but let's have a look about for whom it's most helpful. What you're seeing here, and this is a chart I like quite a bit, you can see that the world champion in chess, if you just look at the ELO scores, getting better and better and better, but just slightly. By contrast, chess computers are getting much, much better all the time, okay? If you're wondering, in 2000, you're surprised that the chess computer were not better than the world champion, didn't Deep Blue beat Kasparov? The thing about it is we are not talking about Deep Blue here. We are talking about commercially available chess computers, okay? Now, what do we find? We see that the chess computer actually only helps you if the chess computer is actually better than you. And it helps you particularly if it's substantially stronger than you. So I give you a simple example. Imagine I try to improve my French, and for Christ's sake, that would be needed, okay? Look, I can only learn really French from somebody whose French is better than my own French, okay? I can only learn from that person. And the better that person is, the more I'm likely to learn, okay? Now, what's the effect of this? Okay, if you think about it, so it turns out that really the weak players benefit first from chess computers, right? Because if you're a very good chess player, in these early days, right, when chess computers come out, right, in this kind of time period here in the 1980s, if you're already a grandmaster, you don't benefit much from having access to a chess computer because it's like, you know, like I'm already better than the chess computer. I'm not even gonna bother playing with this. Okay, but so what's happening now, if weaker players tend to benefit more, there's catching up. Okay, so I give you an example from a setting which I like quite a bit. If you're a native speaker in English, okay, the style suggestion in English don't typically much do for you in Microsoft Word. If Microsoft Word says like, you know, you can write this better, your grammar's off, your typos are off, you know, if you're a native speaker, the effect on you might actually be rather small, if there's one at all. You might actually say, this style suggestion is stupid, I'm going to ignore. However, if you're not a native speaker, you might benefit a lot, okay? Because this is really geared towards people who are really kind of struggling with it. And the eye in that moment is much, much better. So what you see in that period is that weaker players start catching up. Okay, so the competition suddenly gets more dense. Okay, so, you know, think about it the following way. If you're a very good programmer and you're competing with somebody who's not such a good programmer, you might actually better watch out because you see, like, that person might catch up to you using ChatGPT rather quickly. There might be specifics in your industry why this is not the case, but generally you want to be worried about these kind of what's called a heterogeneous treatment effect. Some people benefit more from it than others. Okay. Steen, I don't know the answer to your question, but my guess would be yes. My guess would be yes on your question. So let's go to the mechanism. Is it really the substitution? The simple answer here is yes. Okay, we are saying there's a bottleneck of scarce human training partners by constituting a scalable substitute. Okay, now we would expect that the effect of having access to a chess computer depends tremendously on whether you have access to human chess computers. And this is exactly what we find interestingly. if you're living in a country where there are lots of chess tournaments where you can play easily against a lot of people, you don't benefit that much from a chess computer. By contrast, if you live in a country where there are not many opportunities to train, then you benefit much, much more. So you're really in need of training partners. Okay. And it turns out actually that people then start foregoing. You see, like the moment they can actually train with an AI, they don't rely so much anymore on training with humans. All right. So last but not least, are the learning outcomes comparable? And for those of you who've made it until here, I think this is almost a little bit like the, how should I say, the ice on the cake. I think it's the most interesting finding of the paper. Okay. Look, the question is, are artificial training partners perfect substitutes for human training partners? So do you learn exactly the same when you train with an artificial training partner as when you learn with a human training partner? So, and there's something very interesting about it. So we compare the training partners. And now there's an interesting feature. Strategic interaction is very often about exploiting the mistakes of others. So somebody else conducts a blunder, and then you exploit that. Okay? So if you train against the computer doesn't make a mistake. And so you don't learn to benefit from other people's mistake. Okay, let me say this again. An important part of competitive interaction is to explore, to notify and to exploit the mistakes that your opponents make. Okay, but if you're only training against computers, you're not being exposed to mistakes. And so you're not becoming better in notifying and exploiting mistakes. Okay, so the funny thing about it is, while generally people who train with AI become much better, they are not becoming much better in exploiting blunders that other people make. Okay, and we can see this nicely. Obviously, if you look at the chance that you win the game, right? So this is the dependent variable here. If your opponent makes a blunder, that goes up tremendously. Okay, your chance of winning that goes up tremendously. But if you have access to chess computers, that actually tends to have a negative effect on your kind of the effect of blunders on you winning the game. Look, we've already discussed a lot of the implications here. Okay, how can you now use this in your personal career? So what I've been doing is I've started developing like a bunch of tools and in collaboration, sometimes with companies, sometimes on my own. So if you're interested in this, just follow me on LinkedIn or like send me a message on LinkedIn, where people basically use GenAI to train different kind of social interactions. So I give you a prominent example. So for example, for large scale companies, like let's say you're a large scale service company like McDonald's, it's very difficult to actually train your employees in customer interaction. The reason is simply you have an enormous amount of turnover. Okay, there's an enormous amount of turnover in that industry, and it might just not be worth for McDonald's actually to train those people in great detail. And you can't really hire like an expensive coach and send them in every kind of McDonald's franchise to train them. But so you might actually using AI to train these people in like complaint management and stuff like that. Okay, obviously managers can also learn different kind of strategic interactions. Okay. That's pretty much what I got for you. Two things I would point out as we kind of conclude. I think I already shared. So you can follow me if you want to. You can follow me on LinkedIn, okay? Or you can feel free to also connect on LinkedIn. I will share more research on AI. I'm also happy to kind of send you the link to the paper. So how about I share the link to the paper after we've talked? So if you want to kind of read more in detail about the paper, you want to read the paper itself, so I'm happy to share it. So just kind of connect or follow with me on LinkedIn. I actually like when you connect, that way I can kind of, we can chat a little bit. The other thing I will do is we have another webinar on the topic of AI coming up. It's my great pleasure. We're going to have Ethan Mollick, who's going to talk about kind of the effect of AI and how you can make use of AI in your life and in your career. And we're gonna have a webinar with him, I think about 2 weeks from now on April 5th. I'm going to put that link also in the chat. We already have like 200-300 people signed up. Ethan Mollick is, I think that's fair to say, one of the absolute leading intellectuals on artificial intelligence these days. So I'm very excited. He's a professor at the Wharton Business School. So I'm very excited that he's agreed to join the INSEAD webinar. The INSEAD webinar is freely available. I don't know if we have a limit. We might have a limit of like, there's a limit of typically in how many people can sign up. So I suggest you sign up soon. Otherwise, I'm getting the message here. We have hit our time limit. Thank you so much. Don't hesitate to contact me if you have any questions. And yeah, connect on LinkedIn. I'll share the paper and stuff like that. All right. Thank you so much. Have a wonderful time. Bye. And yeah, take care of yourself. And if you can, take care of somebody else.